Welcome back to a new episode of Automation Digest. Today we'll be talking about DSA. If you attend any of the interviews, DSA is a must. Every tier 1 and tier 2 organizations will definitely give you some questions related to DSA. So we'll discuss about them. We'll try to solve problems so that you are prepared by the time you go for the interview. The problem that we have considered for today is something related to move zeros in Leetcode. It's an easy problem. It has been asked in many of the interviews. Before attempting any of the programming challenges, the first and foremost thing that we have to perform is understand the question. Once we have understood the question, we have to design test data. Once we have designed the test data, we have to derive a solution. Going forward, we have to dry run the solution that is prepared. Then we would be writing the code. So first, let's understand the question. What does the question say? It says that it has an integer array called nums. We have to move all the zeros to the end while maintaining the relative order of the non-zero elements. There is a specific note mentioned over here which says that we should not be creating a copy of the array. There are some examples given. And there is a constraint which talks about 1 less than equal to nums.length less than equal to 10 to the power 4. The value of numSi can be anything in between minus 2 to the power 31 to 2 to the power 31 minus 1. Also, on the right hand side, we are given an integer array called nums, and the return type of the method is void, which means we don't have to return anything. We just have to make sure that the integer array nums should be arranged according to the questions provided. How do we perform this? The first thing that comes to my mind is to swap the numbers with the zero wherever it appears. Let's assume this is our array, which means we have 0, 1, 0, 3, 12. The length of the array is 5. We have to consider 2 pointers, left and right, which at the beginning starts from the position 0. We will continue to verify till the right reaches the end. Now, we will consider left and right to start from 0. We will see if the first element is non-zero. In this case, it is not a non-zero number. So we'll move right to the next element, which is 1. Now, we will see if this is non-zero. Yes, it is non-zero. So what we have to do is, we have to swap the right element with the left element, which means this gets replaced by 1, this gets replaced by 0, and our L is incremented by 1, which means our L now comes to this position. Next, we move the right pointer to the next element. We verify if that is a non-zero element. It's not a non-zero element. So left stays as is. The right moves to the next element. It checks if it is a non-zero element. Yes, it is a non-zero element. Now this element or the element at the position right gets swapped with the left positioned element, which means 3 goes here and 0 comes here. So this becomes 3 and this becomes 0. Once this is done, the left also has to move 1 position to the right. The right now moves to the next element. It checks if this is a non-zero element. Yes, it is. So it now swaps itself with the element in left position. So this gets changed to 12. This gets converted into 0. Because right reaches the end of the array, we stop there. At the end of this loop, my output says 1, 3, 12, 0, and 0. So if we see, the solution is as per the question. The non-zero element retains the order 1, 3, and 12. The zeros are placed at the end of the array. This is one way of solving it. But if we solve this problem with this approach, we have to swap as many times we find a non-zero elements. Can we avoid this swap? Yes. If we consider the same array, we can have one loop wherein we have the I which traverses through the array. We have another pointer called position which will be incremented as soon as we find any non-zero elements. We are not going to swap. We are just going to replace the number with our non-zero number. What I mean to say is, for the first iteration, When I equal to 0, I encounter 0. There wouldn't be any change. I moves to the next element. Here it encounters 1. This number is just replaced in the position, which means this becomes 1. Position is now moved to the next element. The element at I index is not changed. This remains as is. We move I to the next position. In this iteration, it encounters 0. Again, no change. The next iteration, it encounters 3. It replaces the number at position. Position is at index 1. This 1 is now replaced by 3. There is no change to the 3 done yet. The POS again moves to the next element. Our index I also now traverses to the last element in the array, which again is a non-zero number. This number now replaces the number in index POS. So the 0 is now replaced by 12. No change to this number is still done. After our loop completes and I has traversed throughout the array, we create another loop from position to the length of the array to have every number replaced by 0, which gives us a result of 1, 3, 12, 0, and 0. Both the solution works fine if we consider the time complexity. The one that we discussed just now has a better efficiency than the previous solution. We will try to solve this in both the approaches and we will check the time taken by both of them. In the first approach, we had to take 2 pointers, left and right. Remember, we started with both the pointer at 0. We have to start the loop. Here, nums.length gives us the size of the array. The check that we have to do inside it is if the number is not equal to 0 or a non-zero element. Whenever we encounter any such number, we have to swap the number. We will take a number, let's say 10, and we will initialize it with the number right. Next, what we do is we assign right with left's value. Next, we assign left with the temp value. This should swap our number. Once we have concluded this, we should increment our pointer left. And at the end of if condition, we have to increment the right pointer, which means every time, no matter it enters the if or it does not, the right has to get incremented by 1. If we run this problem, we would see that both the cases has passed. If we submit the solution, we would be able to see that it has passed, which beats 42.25% people. Let me perform the same problem with the other approach. We require 2 pointers again. So we'll keep it as left and right. Now, we want to traverse throughout the length. Because right is already initialized at the beginning, I am skipping the initialization part in the for loop. I will have a condition for right to be less than nums.length. Moving forward, we will increment right every time. Here, we are again checking for the same condition, which is if nums of right is not equal to 0. If it is not equal to 0, I'm just having the value copied to the left. So, and I am incrementing left. Once I am done with this, I need to have another for loop. This time, for the left index to move from its position to the nums of length. So again, I will skip the initialization part for left. I will check if left is less than nums.length. And I will increment left every time. Inside this, I don't have to worry about any condition. I am just going to have every value initialized to 0. If I run this problem, I see there is one extra curly brace, so let's delete it and I will run this problem. Both the test cases have passed. If I go ahead and submit it, this time you would be able to see that it beats 100% with a runtime of 1 millisecond. Because there was no swap involved, this was relatively faster because it was just assigning the value once instead of having 3 assignment statements for swap. All right, that's it for today. I hope you liked the video. Please do not forget to like, subscribe, and share. Thank you. Happy coding.